is some tips that I gathered and tools that I use when I'm building Gen AI applications. Right? So I've been building Gen AI applications for the last few months, and I'm going to show to you some of the tools and the things that I've been picking up as I go. For those that don't know me, my name is Juan Peredo. I'm an IT consultant, I'm an entrepreneur, I'm an architect, and everything in between.
What?
Yes, sir.
You're not sharing on Zoom.
I am not sharing on Zoom. I thought I did. We can fix that. We have the technology. Hello. All right.
We're good.
Perfect. Let me make this small. And there we go. Okay. All right. Cool. So some of the things I'm going to be talking about today. There we go. Better. So first of all, let's talk about what we all been hearing all along, right? AI is going to help you be more productive. AI is going to be make you build a website in like 10 seconds. All you have to do is talk to them. And we all know that doesn't work quite like that. But there are tools that will make us more productive, right? On the left-hand side here, you have Copilot and Amazon Q. Those are some of the first ones that came out, right? Copilot with Microsoft. Just show of hand, who uses Copilot here? Good, it's a fair amount. Amazon Q is, if you're doing AWS stuff, great. Q will help you out significantly. The one I'm using currently is Codium. Codium is free. You can, or if you want the advanced feature, you can have a small monthly payment. I think it's really good. And the ones on the left are the ones I'm going to try next. And especially Cursor. Cursor is a full-blown IDE, and I heard really good things about it because it puts the whole context of your whole repo into memory. So it's supposed to be giving you a lot of very good recommendations. So it's more than just autocomplete, which is what we use Copilot and all this most of the time. You can always use another LLM, use copy-paste, right, into the window of the LLM. The one I'm using currently is DeepSeek, version 2.5, I believe it is. And I think they just got out a new version yesterday or today. Really good, recommended. And there's a whole bunch of other ones, too. And it really depends on what you're doing, right? If you're doing Python, boilerplate, you can pick pretty much any of the coder LLMs, and it will do a great job. It will give you all the boilerplate. If you're doing something more niche, like let's say Svelte 5, which just came out a couple of months, then you probably want to do something with OpenAI or DeepSeek that have bigger knowledge. But even though these tools help us, they also hamper us, right? Because if you start using AI in your applications, it's no longer your typical components that you have to build, right? We still have to use front-end, back-end, pipelines, all that stuff, right? But now you have to worry about all this stuff that's here in gray, right? Now you have to figure out which model you're going to use. Are you going to train it? Are you going to use RAG to hamper hallucinations? How are you going to evaluate this thing, right? And one of the big things about AI nowadays is that it changes constantly, right? There's new models coming out every day, right? And you can't just replace one model with another and use the same prompts. You may get the same results, you may not get the same results, even if it's made by the same company. So evaluating these models is extremely important. Another important thing is how you're going to host this thing, right? GPUs are at a premium, yeah? And they're expensive, right? So you have to decide how you're going to host it, where you're going to host it, and that's beyond your typical application. Right? For example, if you wanted to host this with Lambda, right? Lambda has a limit on the memory and the size of the container you're running, so you can't put a huge model in there. Right? You might be able to put a smaller one, but then you have to worry about performance. Right? So all these things are things that you have to think about nowadays that you didn't have to think about a year ago. And then we're talking about hosting, right? So if you want to host it locally, there's a set of tools. Olama, which literally allows you to just plug it into your laptop. You can run it as a container, and you can run dozens and dozens of models that you can train on your machine, as long as your machine is beefy enough, right? I used to have an Intel Mac. Yeah, I tried to do inference on that. Good luck. I could sit there for half an hour and still thinking about it. I have something better now. You can also host it on the cloud, right? And you have the usual suspects, right? You can put it in Google Cloud, AWS, IBM Cloud, Azure, right? Or you can pick the smaller providers that will actually run your containers in the cloud, but that are making it in a way so that you can just deploy it, let's say, into model. A model will figure out which cloud to actually run your container on. And that depends on how you've configured it, what GPU you need, for how long do you need it. And if you're using Python, which a lot of us are here doing AI, if you're using Python, model is perfect. I fully recommend it. I'm using it. You basically can just decorate your functions that are doing inference, deploy it to model, and it will deploy it to one of these cloud providers. You don't even need to know which cloud provider if you don't care about it. SkyPilot. SkyPilot is great for controlling your costs. Right? SkyPilot is the same way. You create your container, and it will go and create your LLMs on the cloud, and it will deploy into 1, 2, 3 clouds, depending on how you want to do it. It's a great tool to get you going quickly. But it's no longer 2023. We all know building a chatbot, dirt simple. You can do this in half an hour, if that much. But we all know that the answer is not what you're going to be expecting, right? Like what we have here on the right? What's 3 plus 3? And I actually had this happen to me where it says 33, right? So building a chatbot, dirt simple. Making sure that it gives you the right answer, really, really hard. So there's things that you can do, right? And a lot of people here have probably heard about many, if not all, these things. First of all, prompt engineering, right? Making sure you have the correct question in the correct information that you're passing to your prompt, right? But when you're doing this, when you're doing prompt engineering, you have to be very precise, right? The other day I had an LLM crash on me because I tell him, give me information about John. And John had a lower J. And the LLM crashed because he couldn't find John in the database. So all of a sudden I had to add to the prompt, I had to say, ignore case. And then everything started working again. It's crazy, but it's true. LLMs are very smart, except when they're not. The other thing is putting guardrails, right? And this, when I talk about guardrails, I mean a secondary LLM that you run before your main LLM that will actually classify the question. A good example of this is LlamaGuard, right? You basically have somebody sends a prompt to you, you put it through LlamaGuard, and LlamaGuard will tell you whether this is something that is breaking the law. It will tell you whether it's breaking intellectual property. And then you pass that. If it's safe, then you pass it to your application. Then you have RAG. Is anybody here that doesn't know what RAG is at this point? RAG, retrieval augmented generation, is basically you take a bunch of documents, break it into pieces, store it in a vector database, and then when somebody asks a question, you a similarity search in the database, pull pieces from there, and then you give that to the LLM so that the LLM can reply based on that information that you're providing it, rather than using its own knowledge. Okay? Oh, retrieval, augmented generation. Yeah. The problem with RAG solutions is that depending on how you chunk your documents, you may not give enough information to the LLM to actually provide you the right answer. And at that point, it hallucinates and gives you whatever it thinks you're thinking you want to know. So it's highly dependent on the data that you're putting. So for example, if a customer did this, they put thousands of documents into their vector database, including stuff that was not good anymore. And all of a sudden, they started pulling all that information, and the chatbot started pulling information that wasn't good anymore. Right? So it's very important that whatever you put in, you're aware that that's what's going to come out. And then there's fine-tuning. Fine-tuning is actually teaching more stuff to the LLM. Right? So putting it through some more training. The problem with that is that, one, it's very expensive. Two, very time-consuming. And more important, there's no guarantee that you're not going to degrade your LLM. And what do I mean by that? That means that the LLM may actually forget some of the information already it knows, or get confused with the new information that you're giving it, and not giving you good answers anymore. So bottom line, there is no guarantee that the LLM is going to work the way you're expecting. You have to constantly evaluate what's going on, constantly evaluate what information the user wants to get, and whether the answers that you're providing are good. The choice of your provider is very important, as well as the choice of your model. Right? So we all know ChatGPT, their models are really good. But if we see here on the left, you will see the price is like over 20 times what it would take you to run an LLM with Llama. Right? Now, do you need the power of OpenAI? Right? And the answer may be yes. Right? And you're willing to pay that price. But 90% of the time, I can guarantee that you don't need that kind of power. And you can create either one smaller LLM for a smaller question, or chain multiple LLMs to get to the answer you're looking for. Right? So it's up to you. What do you want to do? Just keep in mind that there's a price to running each one of those LLMs. The other thing, that output speed is very important. Right? Now, the biggest problem in building applications nowadays with AI is how long it takes to run things. Right? We all know that our users are used to waiting for sub-second answers, right? Anybody that clicks a button on a web page and is more than a couple of seconds, they go away, they go somewhere else. Right? So output speed is extremely important. So which model and which provider you use to get those answers is very important. Now, here for this particular Llama 3.1, Cerebras and Grok, their inference speed is significantly bigger than anybody else's. But it really depends on what model you're running. And you have to really evaluate those models, like I mentioned before. And you have to evaluate them at all steps of the life cycle, right? So when you're first starting, you may start with a Llama on your machine. Just try some LLMs, see what works for you. Then if you want to try some open source models, you can go to Hugging Face. You can create spaces. It's really, really easy. There's a lot of examples over there. There's a lot of code that's there already written that you can just pick and use to test LLMs. Um, the other thing that I really like and that I use every day, Open Router. They have dozens and dozens of LLMs that you can just plug in and play with. It's dirt cheap. I think I put $50 on it 6 months ago. I still have credit. And I think I have like $30 on it still. And I use it every single day. And another great thing about Open Router is that it will actually route your query to the cheapest provider. Right? So they will basically, if you're trying to run a Llama model, and there's 5 different providers, like Fireworks and Grok and blah, blah, they will figure out what's cheaper at that particular point in time, and they will run your query against that. Right? Now, obviously, if you're going to do that in production, be careful, right? Because you really want to make sure that you're not opening a potential backdoor. But for testing, this is a great way to do it. And the last thing over here is Langsmith. This is not a LLM provider, but this is a way to evaluate your model output, right? So anything from speed, whether it's sticking to your RAG is sticking to correctness and all these other metrics. Langsmith, which is by the makers of LangChain, is really a great place to go and play with. And there are other solutions out there, obviously, but I've been using Langsmith, and I really recommend it. Any questions so far? Yes, in the back. Mm-hmm. Mm-hmm. So there's 2 things, right? There's cheap and fast, right? And they both work together, right? So there's the per token cost, and there's the duration, right? How long it takes for that to run. My favorite way to run Llama models nowadays is in Grok. It's just speed, just flat speed. And right now, if you are just testing, you can get an account with Grok, and it's free. Grok, G-R-O-Q. It's free. As long as you're a developer, it's free. And then once you're starting to go to production, then you can talk to the salespeople. But it's a great way to do it. Any other questions? Yes. Mm-hmm. Mm-hmm. Yeah, the secondary, so for example, LM guard or Llama guard is a very small model, and it's basically a classifier. So it's not half as powerful as your main model. So, mm-hmm. 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 Yeah. So let me rephrase, let me make sure I understand what you're saying. So you want to have a primary LLM that's small, so one LLM that's small for your smaller tasks, and then a bigger one for big things that are bigger. Absolutely. Absolutely. That makes absolute sense, and that's the way. When I'm doing things like translation or summarization, for example, I use Mistral Tiny, which is Mistral 7B, I think. Right? I don't need anything beyond that. We're not cutting corners. We're just using the correct size LLM for the correct task. Yes? Well, let's go back to, I'm going to talk about agents in a second. So let me go back to your question. Yes? Mm-hmm. Let me get back to your question. It's the same as same. We're going to talk about agents in a little bit. Okay. All right. Another thing that is very important for us to do when we're doing AI applications, externalize your prompts. It is very tempting and very convenient to just put your prompts in your code. And I know a lot of us do it, right? But if you put your prompts in your code, that means you cannot collaborate with people that are not coders. So your experts that know about the particular subject that you're building the application for, they can go into your code. But if you externalize it and put them in something like LangChain Hub, then you can give them access, and they can go and play. And they actually can change the prompt, run the LLM, see what comes out, change the prompt, see what comes out. And then when they're ready, they'll commit their changes, and that can flow directly into your application, making you go a lot faster than if you had to change the code yourself. So let's talk about agents, right? And agentic applications, whatever that means. But basically what it is you're going to take an LLM or a number of LLMs, and you're going to connect them to code so that they can do things like translate a book and then summarize it, right? Here we have a simple on the, what is this, the left. I know where my left and my right are. That's a plus today. We have a simple assistant, right? Basically, you start, you give a request to your assistant, the assistant uses some tools, which could be, once again, summarization, for example. And then they write a report. They use tools for writing the report. And then when everything is done, it ends. Right? And this particular picture is right out of the LangGraph website. But it's something that is really easy to do. It's really easy to build, but it's very, very powerful. Right? All of a sudden, you're not just having that chatbot that just replies to the user. All of a sudden, you have a system that can do tools, that can do business processes for your user. Another one that's very, very powerful, and it doesn't look like it's very powerful, but it's this one. So you have an assistant, and let's pick, for example, Llama 70B. Llama 70B is really good at function calling. Right? So you can build, let's say, 10 tools, which are fancy names for functions. You can build 10 tools, and then you tell to the assistant, I want to process this document. And the LLM goes and figures out, well, in order to process this document, I need to call these 5 tools, runs each one of them in sequence, and then ends and gives you the output. Right? So that's basically what it's doing here, right? So it comes here, runs a tool, am I done? No, run another tool, am I done? So on and so forth. And one of the great things about platforms, and it can be either LangChain, it can be CrewAI, there's LangFlow, there's a bunch of these tools nowadays, is that they make it really easy to do things like concurrent calls or branching. So for example, here, it could be your agent here that's doing summarization and translation at the same time. So all of a sudden, instead of your process taking 10 seconds, 10 seconds, 10 seconds for each tool, all of a sudden you have 15 seconds because you're running things in parallel. And we all know that running things parallel. Concurrently is not the easiest thing to do, right? And in Python, the model is iffy. But these tools make it really easy. Does that answer some of your questions on agents? And one of the things, and I put it back here, I truly believe that the agents are the future of development with AI. Right? Yes, AI models will get more powerful with time, but they will always need to have access to something to interact with the real world. Get proper observability for your tool, for your LLMs. And I can't emphasize how important this is. Doing printing and trying to figure out what 10 LLMs did in one run, it's really, really hairy. Not to mention that the LLMs will do the right thing 100 times, and then the 101, it will break. And you will not know why. You'll have to go and change your prompts, et cetera, et cetera. This is samples of traces in Langsmith, right? Where it will actually trace. Here I'm running, for example, Llama Guard. Then I'm running Llama 3.1 8B. And this is a place where the output of the error. Right? And one of the things is like that happens a lot of the time. Well, not a lot of times, but happens sometimes. Is that it will actually, the LLM is so bent on answering your question that we will run that call, it'll get an error, and instead of reporting the error back to you, it will actually try running every single other tool to see if it can fix the error itself. And all of a sudden, your agent, instead of costing you 20 cents, costs you $1.50, right? And it takes a minute or 2 minutes. If you don't have this kind of tooling, well, you can even build it yourself if you wanted to, but build it, because if you don't have it, it's going to be really, really hard to figure out what's going on. And with that, any questions? Go ahead.
So, coming back to the point that you made, like how you inject the prompt in the code itself, then it becomes kind of closing the way we can interact with LLM, because there's not many prompts that you can put in to get something done out of it. So I'm kind of I'm one of the main members of the AutoGen, so that's the Microsoft agentic pipeline framework. So in that we have written some pre-coded prompts, and that's the problem that we're seeing right now, because the prompts are already embedded in the system, and if the agent fails at one point, kind of coming back to the thing that, oh, I can connect this thing, and instead of costing 20 cents, cost $1.20 or something. So what is the best way to mitigate that problem without having some pre-embedded prompts to get around this one like 5.2?
There is no guaranteed way, right? You can mitigate it, right? First of all, take your prompts out of your code. First, that would be the first thing I would do, right? Second thing I would do is you have to put more guardrails on your prompt itself, right? So you're gonna start noticing it fails because you've asked him X, Y, and Z. You're gonna have to put additional conditions on your prompt for that. Other thing that you can do is you can break that particular prompt, right? So like we had in that slide with LangGraph, right? Instead of having a single call to one LLM, have multiple calls, right? So have a classifier at the front that classifies this is this type of question and send it to the correct model first, and go from there. It should be dependent on the type of question that's been asked, right? Right? Yeah. So I was having problems with one of my LLMs because one of the tools that I was giving it was RAG, and then it had other tools. And then when I was asking that question that was related to RAG, it wouldn't always figure out that it had to go through that path, right? And it would just start calling tools like crazy. So I put a classifier on top that says if this is a RAG question, go this way, otherwise go that way, and that got rid of that problem. Yes? Mm-hmm. 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 How do you go about the stability? Mm-hmm. 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 Yeah. Yeah. And this is more, and this is, I'm assuming, a RAG application, right? All right. So there's a new set of embedders and that allow you to do multimodal embedding, right? So the problem with text embeddings is that you're really chunking small pieces, and when you're chunking those pieces, especially if there's tables and images on your document that may have the correct information, first of all, it may not put it in the correct order, so all of a sudden things don't make sense anymore. And second of all, it's only going to retrieve small pieces. Now, if you do multimodal, now all of a sudden that table is actually embedded as a table. And then you can, it will just, doing the correct similarity search, it would pull the actual table rather than just pull parts of it. Yeah. Yeah. Yeah, look at, I think it's Colipali and Coligema. I think those are the new ones that just came out. Take a look into those. Yeah. Anything else? No? All right. Well, thank you very much. Let me go that way so I don't trip on the cable. Oh, good. Thank you. Yes, sir. Oh, yeah.
You know what? It wants me to quit and reopen. I'll join back. I had to change the. Okay. Test, test. 1, 2, 3. Testing.
Testing.
Oh, for the stream. Oh, okay.
Does it work well?
Testing, testing.
Yeah. Oh, are both mics on? Or?
Yeah. We're dropping. I'm sorry. Yeah.
All right.
It's a good way to put this on like this. I feel like I'm doing a TED talk. Oh.
Filter.
Oh, okay. So we can switch it off?
No, it's fine. You can still work it.
Okay. All right. Awesome.
Here we go. I'll share. Allow.
Thank you guys for presenting.
Oh, no, thank you. Yeah, no, thank you for having us. Let's see. Am I? Uh-oh. I'm in, right? It says I'm sharing my screen. I don't see it up here, though. Let's see. I'm doing something goofy. So I see that I'm sharing, but
Do you know how we could get it up on the screen? I think you got to make it full. Maybe if you hit present.
this. Oh, here you go. Oh, you know what? That
It's weird.
I wanted to share.
Just share your entire screen. Yeah, desktop one.
Sure. Just jump
That
on.
should fix it, right? All right, it's already back.
Let's see.
Yeah.
Oh, see.
Oh, it's because of speaker notes. Can we delete the speaker notes? Or
See, so it's like desktop 2. Should I share?
maybe if you yeah,
Oh,
just
this.
share that.
I'm sorry.
We'll see. Hopefully that works. Otherwise, I'll have to share, I guess. But I don't have the Zoom link either,
That's
and I don't
really
have Zoom, so
interesting.
it's got to be you.
I wonder why. You see how? Because I have this here, but it's really curious. I'm like,
Any idea how Juan was able to do it? Any idea how Juan was able to do it? Otherwise, perhaps Keynote. Do you have Keynote?
yes. Yep.
Oh, yeah, on this it's fine. But when you're sharing, I think there's an option.
Let's see. Oh, I see what you mean.
Not on Zoom. Zoom
Oh,
is
oh,
fine.
oh, oh, okay.
On Keynote itself, when you're sharing.
Oh, I see.
This
You know
is PowerPoint.
what?
Oh,
Yeah.
PowerPoint? Yeah, well, also
Oh,
PowerPoint.
I see what you mean. So let me go back
Yeah.
to.
Oh, it's the present button.
Oh, let's see. Go with PowerPoint, and then
Do you know how to play,
Yeah,
like
just,
present?
Just minimize, this is
minimize
fine.
this.
Yeah.
Oops, we'll move this out the way. It's this.
Do you know what the play button or present button is on
Oh,
PowerPoint?
right here. It's
Yeah,
this.
this one.
Mute it.
Right, but that's
Oh, yeah,
causing
move
the issue.
it. Oh, good. There we go. Yep. And then it's this, right?
Yeah. Oh, it's showing both.
Oh my goodness. Sorry.
Do you know how to?
Juan ended up doing it. He had to close out all of his, but you
Where's the
can.
cursor? Oh,
Yep, there, yep.
is it
Do you have
extended?
Keynote?
I do. Well, I can pull that up.
Let's try the Keynote version.
Okay.
Wait, I'll have to send a Keynote version. Give me one minute.
Oh, layouts. Maybe something here.
This right here.
Yeah, try that.
Oh, like,
Oh, what is that? No. Go to this one.
this.
And this is for Zoom, I think. This
Oh, I'm
should-
sorry. Sure,
Yeah.
yeah, sure. Like this.
And then when you stir it, you can mute your.
Yeah. So Zoom.
Yeah, you're muted already.
You got it. Yep.
All right.
And then see how.
Present it. Share screen.
Oh, you got it. Yep. So
Let's see
present.
if we could use this.
Oh, we're gonna go. Okay, gotcha.
Replace real quick. Show and Finder.
Oh, see, maybe like a.
There we go.
Oh.
It'll screw up the. It'll screw up the Zoom. But I think it's fine. No, or what do you think?
Yeah, because that's being recorded, right? What happened? How come this came over here?
I'm
interesting.
using Keynote now.
It's okay. This is fine.
I guess this will have to work, right?
Yeah, it'll still work.
And the Zoom doesn't show this. Oh.
It just shows the.
Oh, this. Okay.
Yeah, it just shows the next slide. So
Did you want?
I think it should be fine.
Oh, next slide is
Oh
fine.
no, I think I'm all set. I appreciate it. Thank you so much.
I think we should be set then.
Yeah.
And then I'll just ready? And then. Sorry, guys.
Yeah. So
Ready?
ready to go? Yeah. So thank you all for joining us today. Our conversation isn't going to be deeply technical like most AI camp presentations, but rather we want to educate everyone on the more practical use cases of AI and specifically the various use cases of AI within the business world. And in particular, how and where IBM today is utilizing AI to provide value to large enterprises. So just a quick intro, Matt and I are pre-sales platform engineers at IBM. Please feel free to reach out to us on LinkedIn afterwards. We work with teams to support clients on their digital transformation journeys by showcasing the value of IBM solutions and services. This often entails us working on customizable proof of concepts and helping our clients solve various IT needs. Do you want to jump in here?
Oh, sorry.
So to preface, IBM is a large and significant technology-first company that has been at the center of American technological innovation for the past century and today ongoing.
We could go.
So IBM has been involved in all aspects of technology, whether it be hardware, software, cloud, specifically cloud computing, SaaS, and now generative AI. So IBM has been at the pinnacle of AI and continues to innovate towards an exciting future for the entire AI space. In fact, IBM was one of the earliest, in as early as 2011, to showcase IBM's Watson AI system, defeating Jeopardy champions. This Watson victory was one of the first times people saw an AI system that uses natural language processing. So it was shocking for many to see. Yeah, there we go. So nowadays, all firms that have survived into the 21st century, for the most part, have become technology companies in one shape or another. But now with the massive transformation taking place, many companies are now transitioning from merely adopting AI and adopting technology to becoming AI first. So what that means is they're taking an AI-centric view on how they approach various business challenges and solve problems. So if there's any business-related problem out there that can be solved by technology, IBM is and has been involved in the solution. So our clientele are from every industry, no matter how big or small, but being that we are enterprise-centric, our primary clients are the Fortune 500 companies, including over 90 of the Fortune 100 companies. So although IBM has been at the forefront of this generative AI research from the very beginning, the release of ChatGPT in 2022 has sparked a massive interest in Gen AI across the entire space, and every business across every size, geography, and industry. So adoption and interest of AI is only growing more and more each day, and the data suggests that the growth in enterprise adoption of AI is due to continue to grow, especially among early adopters. In fact, 75% of CEOs say their competitive advantage rests on generative AI. So it is essential for businesses to get this transition into an AI-first world right and to be early to the game. So placing AI at the core of business will truly transform how we work and empower individuals to make better decisions and deliver faster outcomes by allowing them to focus on the human element of solutioning problems rather than focusing on mundane tasks that are repeatable. So AI will give employees the opportunity to embrace automation rather than stagnation. But this adoption won't come without massive challenges ahead. It is estimated that various barriers keep 40% of companies in exploration and experimentation phases. So in particular, generative AI poses different barriers to entry from traditional AI models and software. Data privacy, trust, transparency, concerns are just some of the biggest inhibitors to generative AI, according to various IT professionals surveyed at organizations not using generative AI. And 35% also cite the lack of skills for implementation as a main inhibitor. And in particular, company leaders face challenges scaling AI in a cost-effective and sustainable manner. To adopt AI responsibly, it is essential to understand how to use and protect data effectively, a massive challenge that companies are still tackling today that doesn't get enough attention. And as leaders adopt AI, they need to consider three factors in particular. Firstly, how to create a competitive edge with AI, how to scale AI across the business, and how to advance AI trustworthiness. We all know of countless examples in our own life, and I'm sure some of you may be that way as well, of students using ChatGPT to automate mundane tasks, to work on homework or answer test questions or whatever it may be. But unfortunately, many employees at companies do not have that ability. Employees at enterprises don't have the opportunity to adopt these open source AI tools due to the massive risks of unauthorized usage of company data to train these models, privacy and IP violations, as well as, of course, hallucinations leading to undesirable outputs that can have massive consequences. So for instance, let's say a lawyer at a law firm wants to summarize or even search for a specific answer within a confidential contract that is hundreds of pages long. By inputting that contract into an open source application, there is now the risk that that confidential information can be leaked, or now even used to train that model. And even more scary, how can we be certain that that open source application isn't hallucinating? So that is where IBM comes into play. Just about every enterprise wants to have their own AI solution that is secure, accurate, customizable, and empowering. And IBM's AI strategy is centered around creating open, trusted, targeted, and empowering AI solutions. In particular, our AI is designed for enterprise and targeted for business domains. And here we have just a few examples of IBM engaging with our enterprise clients to use AI to create incredible outcomes in digital labor, IT automation, security, sustainability, and modernization. So we consistently partner with our clients to co-create solutions for whatever unique problems they may be facing. And given the current misunderstanding and hesitation that many of these organizations have with regards to adopting generative AI, our clients appreciate our expertise and know-how around AI. So going back to that example of the lawyer now, rather than inputting their document into, say, ChatGPT, they can input that document into a company-wide AI application that can produce a safe and trustworthy output that is tailored to the needs of their specific industry and company. So this could mean having the ability to train an existing foundation model on their specific company data, or perhaps even use a foundation model that is specific to their industry. Moreover, that AI application could even belong to that law firm and be hosted on whichever environment they desire. So as many of you know, the parameter size of ChatGPT is around 1 trillion, and it's trained on a large collection of data from the entire internet. So this includes elements that may not be relevant to a particular use case that an AI application is tailored for. So for example, if you're a large enterprise creating a virtual assistant chatbot to assist an overworked and overburdened HR department, why would you need or want to use a broad, expensive, and computationally intense foundation model trained on everything from Roman history to cooking recipes, tutorials, or whatever else is on the internet? In fact, you likely wouldn't. Then the next one as well. In fact, it'd be preferable to use a cheaper model that is tailored and could run on less parameters and be trained on company-wide documents, data, and information that is private to a company. Therefore, by decreasing the parameter size, you can create a more targeted, customizable, and cost-effective model for your solution. So we are focused on foundation models for business, whether that mean LLMs, IT automation models, digital labor models, cybersecurity, and many more to come. And we aim to use these models, use whichever model is best fit for what our application is targeting. So in fact, one of the coolest AI foundation models I think that is out there right now has just been released on Hugging Face for weather and climate applications. So this model was actually pre-trained on 40 years of Earth observational data from NASA. And it is used for a variety of weather and climate use cases. So it's all available in Hugging Face, open source to the scientific developer and business communities. And that's just one example of IBM coming together with a business partner, in this case NASA, to create a smaller but more focused foundation model tailored to a specific use case. And IBM takes an open approach towards AI solutioning. We guide our clients to use whatever model may be best for them, whether that be IBM Granite Foundation models, an open source model like Mistral or Llama, or building their own model, or perhaps even a combination of sorts. And as many of you will know, many industries like the financial industry, pharmaceutical, and defense are heavily regulated on the use of their data and often cannot use public clouds entirely, but rather have to use an on-premises environment or some sort of hybrid cloud solution. And that is what differentiates IBM. IBM is a leader in hybrid cloud solutioning, allowing companies more flexibility on where and how they choose to host environments, meaning we give you the flexibility to run our software on whichever environment you desire, be it the public cloud, another vendor, or on your own premises. And then I'll pass it off to Matt.
Thanks, Gus. Good evening, everyone. My name is Matt. I'm here to talk to you about watsonx and a couple of amazing capabilities that we have with watsonx AI, watsonx Data, and watsonx Governance. So basically, I'm going to talk to you about how to put AI to work with watsonx. watsonx is an AI data and governance platform that helps businesses use AI to scale and accelerate their impact. So bringing down the components to a little bit more detail, we have watsonx.ai. So this can be thought of as like a studio. This is where you could develop your own models, use IBM models, open source models, popular multimodal open source models from some of our partners such as Mistral AI or Meta. Or use a combination of anything that makes sense for your business use case. And so the most important thing about with AI is the data. And we have watsonx.data, which is what you would use to scale your AI workloads with any data type, structured or unstructured. Also, the data can live wherever it is. We're not pulling data across clouds or anything like that. The data can reside where it is. You can have access to it. So it's about using an open data format and makes it easy to turn your data into AI outcomes. Then we have our governance platform, watsonx.governance. So any company putting AI into production needs to immediately start thinking about just, fairness, regulations, am I making the right decisions, and can I explain the decisions that are being made? So those are the three capabilities that we'll be focused on. And the next slide, I'd like to show just kind of the visualization. Here's what a potential solution could look like. So what we have is in, let's say, a containerized environment such as Red Hat OpenShift, you could have the top of the stack, we have our watsonx AI doing the fun model stuff. Under that, we have a layer, our watsonx data layer, feeding our trusted and transparent data into our models. And then kind of wrapping its arm around the whole thing is we have our watsonx governance with providing insight and monitoring our models for any drift or issues that may occur. This could happen in the public cloud, private cloud, on premises, or a combination of any of those. So next, I want to talk a little bit about some of the challenges of AI adoption and kind of go into sort of explaining IBM's point of view and how we approach deploying AI responsibly. Many companies struggle to put AI to actual use, with over half of AI projects failing to move beyond the testing phase. This is often due to a lack of automated systems for managing AI and ensuring trustworthiness. Some of the main issues include difficulty accessing reliable data, an over-reliance on manual processes that are risky and unsustainable, so it's hard to scale. Fragmented tools that don't integrate well. And then also legacy systems not designed for AI. In order to operationalize AI effectively, companies need high-quality, reliable data, automated, explainable tools, and AI-optimized systems to build, deploy, monitor, and update AI applications. The growing complexity of AI regulations worldwide presents significant challenges, especially for global and highly regulated industries like finance, healthcare, and telecommunications. Non-compliance can lead to regulatory penalties, damage stakeholder trust, and incur revenue losses. So balancing innovation with compliance is essential. Similar to how companies adapted to data privacy regulations in recent years, success requires organizations to implement AI responsibly while navigating this the evolving regulatory landscape. So here we have, on the left hand, to your left, there are the 3 fundamental principles of trust and transparency. So overall, this slide's going to talk about IBM's point of view on AI. And this kind of undergirds how we approach our go-to-market strategy with our watsonx platform. On the left, we have the 3 fundamental principles of trust and transparency. First, we have AI's role is to enhance rather than replace human intelligence. So this is about being a multiplier for your human workforce. This is not about replacing folks. This is enhancing people so they don't have to sit in office 10 hours a day doing something mundane. This is, get you home in 8 hours to enjoy your life and to give you higher value work. Data ownership remains with the creators. So IBM doesn't take your data and can do something nefarious with it. It's your data, it's your business. We're not in it. AI systems must maintain transparency and explainability. All right. So on your right, we have the 5 pillars of trust. So this is sort of our point of view on what an AI system would need. Explainability, making AI decisions interpretable for humans. Fairness, ensuring equitable treatment across different contexts. Robustness, managing exceptional cases and abnormal inputs. So like in terms of having a hate, abuse, and profanity filter, and other ways to mitigate risk. Transparency, providing visibility into system design and development. And privacy, protecting user data and privacy rights. So together, these principles and pillars form a comprehensive framework for developing and deploying trustworthy AI systems. So what we have here is kind of how this kind of comes together from an AI point of view. IBM has developed a comprehensive framework for responsible AI adoption. So building on those 5 key pillars that I mentioned earlier, IBM establishes foundational guidelines for responsible technology development and deployment. So internally, we have an AI ethics board, which provides centralized governance and cultivates a culture of responsible technology across the organization. Through their ethics by design framework, IBM offers specific guidance to developers and data scientists for creating responsible AI solutions. IBM takes a proactive approach to regulatory compliance and leverages their extensive experience with their integrated governance program to help clients implement AI solutions that balance speed with trust. So here, let's see, we could probably go to the next one. Yeah. This image kind of illustrates the importance of trust and ethical practices across 3 stakeholder groups. So for consumers, as you see here, 57% are uncomfortable with how companies handle their information. 37% have actually switched brands to protect their privacy. For employees, 69% prefer to work for socially responsible organizations, and 45% will accept lower pay to work for such companies. For organizations, 8 out of 10 socially responsible companies report better performance in the following areas: data ethics, organizational transparency, accountability, and cybersecurity. The data clearly shows that ethical practices and trust aren't just moral imperatives. They're business imperatives that affect customer loyalty, employee recruitment, and organizational performance. So having given what Gus and I walked through, we're going to show you something that takes our IBM's point of view, takes the products that we've mentioned, and package them in a way that we partnered with an organization, the United States Tennis Association, on this really amazing digital experience where we connected. Speaker, yes. Over 15 million participants worldwide. Oh yeah. Yeah. Please let us play that video.
It's on your YouTube, right?
Yes.
It's not sharing the screen.
Not sure. It may be because of. Does it play inside of the keynote?
It does not.
Here, let's stop sharing it and reshare it.
Stop. No, we gotta share it to the screen, I guess, or to the projector. Right, but it's not showing up for some reason. No, not on here.
Does it show up on in the Zoom?
It's showing up on the Zoom because the screen shared. The Zoom is fine, but
Maybe still only doing like the one
I guess
desktop.
we'll just do the audio then.
This world, a place where you can feel.
I guess we could skip the video. We go over it. Oh, yeah, but it's not playing.
Oh, I think there's a way to enable the media. Let's see. Let me see if I can.
If not, we could skip it if we
there's a
can
way
get
to-
it in a second.
There's a way to. There's a way to enable it. I did enable the. I don't think I. Yeah, we can.
I guess we'll
What should we
have to
play the? We can,
skip that. I guess
Okay.
we'll
I can go
skip
right
that.
to it. I wanted to show the video. When I do it for the benefit of the Zoom.
Okay.
This is the U.S. Open, the final Grand Slam of the season. When New York becomes the epicenter of the tennis world, a place where you can feel the pulse of the city. On hot summer nights, under the brightest of lights,
Oh sure.
where champions and challengers compete for one more chance at immortality. But where you see
start it
tennis,
over too.
IBM sees.
Start it over. Oh, got it. Oh, in the back.
No, you're fine.
Okay.
All right, let's see.
It is.
All right.
Cool. Thank you. Here, all set. Here, whoa.
This is the U.S. Open, the final Grand Slam of the season. When New York becomes the
Can I mute
epicenter
this?
of the tennis world,
I think I gotta mute this, right?
feel the pulse of the city. On hot summer nights, under the brightest of lights, where champions and challengers compete for one more chance at immortality. But where you see tennis, IBM sees data. They see every game and every match. They know the speeds, the stats, and the scores. They see the movements of the players and the position of every ball and every point. With the help of IBM Watson X, the USTA is transforming this data into world-class digital experiences in the US Open app, generating spoken commentary for hundreds of match highlights, calculating likelihood to win, and for the first time ever, creating AI-generated match reports for every men's and women's singles match. IBM is keeping its finger on the pulse of the US Open so that millions of tennis fans around the world don't miss a beat. IBM Watson X in the US Open app. Learn more at ibm.com/US Open.
All right. Cool. Thank you. All right. Oh yeah, that's perfect. Yep. And then go like this. And let's see.
There we go.
Cool. All right. So as we saw in the video, IBM is revolutionizing tennis coverage at the US Open through cutting-edge AI implementation. So I'm going to talk about 3 of those major innovations that we saw. So with the AI-generated match reports, these aren't just basic summaries. They're comprehensive analyses of every single match across all 17 courts. Using the watsonx AI platform and IBM's Granite 13B large language model, IBM can generate detailed reports within minutes of a match ending. And what's particularly noteworthy is the scale. We're talking 254 main draw single matches. Each report is reviewed by the USTA editorial staff to ensure accuracy and context before being published. So we're talking, the match reports we're taking on average about 15 minutes, when previously each report would have taken an editor hours. So again, this is not about replacing anyone, but it is about augmenting, enhancing capabilities. And so also another innovation was enhancing the AI commentary system. This was first introduced in the previous year, 2023, but the 2024 version is significantly more sophisticated, with providing automated English commentary and subtitles for match highlights. So the key improvement is that it's more contextual and expressive thanks to the Granite 13B LLM. And these highlight packages were available just minutes once the match ended. And then lastly, we had something called the IBM Slam Tracker. So this is essentially a tennis fan's dream analytics platform. So it provided pre-match analysis with win predictions, live coverage with point-by-point breakdowns, real-time 3D graphics showing current play, and post-match recaps and highlights. So what makes this particularly impressive is how it combines advanced AI technology with human expertise. The AI handles the heavy lifting of data processing and initial content generation, but the USTA's editorial team ensures everything maintains professional standards and accurate context. All of these features were seamlessly integrated into the US Open's digital platforms, both the app and website, making professional level tennis analysis accessible to fans everywhere. So in summary, these are just some of the more practical uses of AI within the business world, and we show how IBM provides our enterprise clients unique, customizable, cost-effective, tailored AI solutions to the needs of their business. Gus, do you have anything else to close?
I think that's about all.
Really my question, the last one, was the practical in normal business on everyday use of that similar?
So with most of our clients, we're under a lot of non-disclosure agreements. So we're very careful to share anything like that.
I'm not talking about the specific name of the client. I'm just saying if you can at least say a word or two on specific cases that you are way of using something like this to analyze all the moves, prediction, and some benefit.
So in the case of the US Open example with the athletics, we have a variety of partnerships with other athletic brands, be it stadiums, UFC, ESPN Fantasy Football, where we provide various analytics, I think Ferrari F1, the Grammys even. So they're jumping in the entertainment space as well. But we decided not to showcase any more business examples that were too specific for that reason. We just don't want to give out a lot of non-disclosure information.
Oh, so if I could play your question back, so you're asking in terms of like where does the data live? Like how do we get it?
So in this example, I'm not quite sure where the data is hosted. When we were saying we don't keep the data, what that means is, so a lot of firms are just heavily regulated. Their data cannot be on a public cloud. And that's what we mean by, in those specific examples of, say, a bank or a pharmaceutical company, weapons manufacturer, their data is privately held within their own servers.
So like
And
companies,
we allow them to run our SaaS on their own servers.
and in some cases, a lot of clients will use like either like a private cloud or on-premises way so that they can keep their data and their the residency can stay within their corporate walls. In some countries who operate, of course, like in around the world, like in Germany, data can't leave sort of those spaces. And so, we're always working within the local regulatory guidelines, and also just some our clients may work in highly regulated industries. They don't want to risk anything. So a lot of times the solutions can run on premises or in a space that meets the client's expectation and need, and also regulatory concerns.
Right.
Does that answer? Did I get you? You still think? Okay.
In the case of US Open, I'm not sure where it was hosted, but
We have a product called CloudPack for data, so you can install it locally. And all your data, everything is local, your data center. So it's basically yeah. So everything is installed locally. So you're not actually going to the cloud in that case. So you're installing all the components locally. So you have total control of the system because it's local. Right, so if it's your data center, you're installing CloudPack for data, you have everything local. You're not connected. You don't have to be connected. You can't connect with the thing.
Yep. That's how our Watson X data works as well. It's like you have connectors that will touch the data where it lives, in the safety of your client or your home or whatever entity that is designated. And then we could pull that information without that data changing its residency.
No, the whole system, what I was referring to is the whole system can be installed locally. So whatever you find on the IBM cloud can be local in your,
Right.
Yeah, so you don't have to connect at all.
right.
If you don't want to. So it's totally in your control.
So with a lot of other hyperscalers,
Yeah.
you're
A lot of environments you cannot do that. Like OpenAI, for instance, right? You have to connect to OpenAI, which is hosted, right? You cannot take that down and install it on your on-prem environment.
right, and you're not limited to a vendor lock-in, say with other firms perhaps. You can run IBM SaaS on any cloud or your own environment.
Yeah, because of Red Hat, it's running under OpenShift, right? All the containers are basically Red Hat OpenShift containers deployed anywhere you want, right? So you can potentially run it on Google Cloud. You just get a bunch of VMs on GCP and then run it there, or your own data center or anywhere.
Yeah, I have a question regarding the explainability and transparency to the payment that we have. But so most of the new models are like deep learning based. We have like thousands and millions of parameters in Netherlands. So what's like IBM doing differently, which is making the AI models more explainable compared with others?
So for my understanding of like the Watson X governance tool is that it takes some setup where you have your model and we have toolkits that will essentially monitor how that model performs. And actually it can be any model. It could be any open source model, IBM models. And it's essentially a functionality of the Watson X governance system where we have ways to automatically monitor drift or if a model is not performing adequately, or if there's like let's say there's some prompts being used that are taking the model out of like a certain performance threshold. You have ways to set up the parameters that make sense for your use case or your application, and the platform itself can, in the form of a dashboard, tell you what your model is doing or not doing.
So are there any PII guardrails as part of the use case?
PII tool.
What do you mean by PI guardrail? Oh, yes. Yes, so you're able to track where PII is on governance.
So if I give a bunch of document size from company's data,
Mhm.
so whatever, and let's say I have the local system on my on-prem container. Okay, let's say it's everything in build, but like I'm kind of using the IBM toolkit and everything. The data is like coming from a local data lake at this point. Will the engineers from the company be able to identify and like train the model, the foundation model to, hey, this is a PII, this is the entity that you have to understand, and you have to redact it, or like you have to consider it. You have to treat it objectively at this point, and so that there's no interference or bias when it comes to giving maybe loans or giving security valuations to someone.
I'm actually not aware of a system automatically doing redaction like that. What we mean by not having PII is in the model. Okay. So the data that IBM uses, it's obviously lens data, and 80% of the data is actually thrown away. Okay. So it goes through a bunch of processes before the model gets trained on. So the model will most likely, no one can guarantee anything, be biased or anything like that, because it went through the whole process, the data biasing, the model bias tests, and all that stuff. And I'll cover a little bit later on this. There's a tool you can use, actually. It's an open source tool that we open source from IBM Research called AI Explainability. So it's on GitHub. You can try it out. You can see whether, but it's not a redacting tool. Okay. So if you have your own model you're training with your own data, no, it's I haven't seen it being like a redacting tool.
So the foundation model is already being trained and
it's like a huge filtration process. I didn't put up the slide on that, but there's if you're interested, I can send that to you. But ping me on LinkedIn. But yes, that's the key to it, right? You start with a bunch of data, then you redacted data and all that stuff. De-identification is also another thing, not just redaction, right? So and certain data, right? If you're looking into the healthcare sector, like genomic data, it cannot actually be de-identified completely, right? You do certain things, but there's problems with that, right? But anyway, so you do as far as possible. That's why almost 80% of the data is going through the process. So you have some validity and fact check and all that.
We're all set. Yeah. Thanks, everybody, for your time. Yes.
Yes, I'm gonna go now.
No, I'm good. All right, nobody leave. You're not allowed to leave.
Hey, no one gets to leave.
Just kidding. All right.
You share it on Zoom.
Is it on the Zoom?
Yeah.
No, did it share? Okay.
I can see it, but it's not on the.
Oh, yeah.
Let's see if we can.
It's weird. It automatically put me into dual screen.
That's something. Yeah. That's what I was fighting with. Let's see. If you go into presentation, does it?
It's not letting me. Maybe if I'm already sharing, then when I.
Oh, we might need your help soon.
Did you log into Zoom already?
Yeah, I'm already on the Zoom and I'm sharing, but it automatically switches it to a second window when I plug that guy in. So like I'm sharing on Zoom.
Yeah. Can you close that window now?
Close what window?
How many do you have loaded right now?
Just one. So what did you have to do?
Stop share. Oh, we actually switched to Keynote because Keynote seemed to work a little bit better. Interesting.
Where's the mirror?
Is there a way to share just a particular application versus the desktop?
Need any help?
Well, it's automatically trying to do multiple screens.
Is this PowerPoint or Keynote?
No, it's Google Sheets. And I'll be doing demos, so I need a browser. But let me try to share in the browser.
So we were using Keynote. That was working, but for some reason PowerPoint wasn't. The interactive portion for us, we weren't able to figure that out.
It's annoying.
I wish there was a share screen. It's connected to HDMI 1, right? Or
HDMI 2.
I'm not sure why that's
I want to see if it has to do with the Zoom. No. And it's not even letting me like choose the multiples. Oh shit. Okay, I know what to do.
Oh, look at you.
I was wondering where the mouse was going. Okay, now. Desktop 2, share. So, but the problem is now when I do my demo, I gotta look over here.
I didn't even think about that yet. How do you move it over to another desktop? That makes sense.
Hey, all right, we're ready. Okay. You ready? Yeah. Okay. So you're all in your pizza comas now. So we're going to start with some exercises with just simple polls. Who's a developer? Developer? All right. Who's like an architect type? Okay. Who's more on like the business side? Okay. Some people raise their hand each time. That's pretty impressive. Okay. So hi everyone. I'm Justin. I'm from a company called Vectara. As you can see, I'm like heavily swagged out in my stuff here with a cute bird on the background or on the back. So I'm Justin. That's Josh on the second row. He's also with Vectara. So I want to talk about hallucinations today. I'm from San Francisco. Not that type of hallucination. The hallucinations with large language models. And the screen's a bit weird because I have to look at that to click and do the mouse and stuff. So bear with me here. But I want to don't worry, this is not going to be like a sales pitch, but I want to give some context on why we care a lot about hallucinations, preventing hallucinations. So Vectara is a RAG platform. Think of it as like a platform as a service, a RAG as a service if you want to call it that. I'm glad that Juan did the poll of who knows what RAG is, and most people did, because that saved me a bit of explanation time. So in short, we're a platform where if you want to build an AI assistant or an AI agent in your application, you just call our APIs. You don't have to do all the plumbing stuff, right? So for us, one step of the process is a generative LLM. So you're only as good as your weakest link. If the LLMs are hallucinating too much, the whole end-to-end thing suffers. So we've spent a lot of time working on hallucinations since day one. And I want to talk about the state of that research in this talk here. And it's not going to go super technical. For those that aren't technical, don't worry. But I want to talk about sort of what we're doing, which is state of the art in terms of dealing with hallucinations, specifically in the RAG context, okay? Okay, what's a hallucination? I think most people probably know it, but it's when an LLM gives a wrong answer or a misleading answer. Or in the case of RAG, an answer that's not based on the facts that was provided to it in the context. And some people call this confabulation, by the way. Does anybody know who's like the main proponent of that term? He just got the Nobel Prize for physics, like today. Jeffrey Hinton. He's like the godfather of AI. He was doing like neural networks before anyone knew what those were. But anyway, he calls them confabulations, so you sometimes hear that. It's sort of the same thing. So yeah, like, capital Washington is Seattle, right? No. See, humans hallucinate too, by the way. It's Olympia. And so sometimes LLMs they do their best to give the right response back, to give the right answer back, but they don't have perfect information. And this is a proven fact. And so RAG can help with this by grounding the responses the LLM provides on a specific set of facts that are retrieved from the data that you give into the system. And so here, the context was retrieved. Someone said, hey, what's the capital of Washington? It found this little snippet in the knowledge base of data you put in, and then it passed that along with a question to the LLM, and it gave the right answer. We're good, right? No. Even then, LLMs still hallucinate, right? They can't not hallucinate. My abstract did that weird double negative, if anyone actually read it. Like, research community hasn't figured out how to get LLMs to not hallucinate yet. We actually worked in the open source, with the open source community with several researchers to put out a hallucination detection model and a leaderboard that quantifies how much the top LLMs hallucinate. And to date, the best one is 1.3% of the time they still hallucinate, which means the inverse of that, 98.7% of the time they're factual. But still, 1%, that ain't great in the business context if you're making decisions on this information. And so there's more to be done. This model I mentioned, you can find it in Hugging Face. It's open source. It's the top hallucination detection model out there. And a lot of time people will just ask GPT, is this GPT-4? Is this information correct and factual? So it's like you're using an LLM to judge another LLM, which sometimes works, but sometimes that's a recipe for getting misleading answers. But anyway, we created this hallucination evaluation model for the sole task of quantifying how much an LLM hallucinates, and it's the top one out there. And we've got a faster and a more accurate version baked into the Vectara platform, as you'll see later. Okay, so we can detect them, and that's a big part. Have you guys ever heard the saying, if you can't measure something, you can't improve something? So the first step in this whole thing is to measure how much these models, these LLMs are hallucinating. But what can you do beyond that? So the first thing that you can do beyond that is actually correct hallucinations. And this is something, an active area of research in our ML team, along with the academic community. And what we're doing here, and we got a blog post with some sort of early information on how that's going and some benchmarks, but you essentially, if you can detect when something is hallucinated, you can go in and like surgically correct, sort of think of it as they're like token predictors, like what should come next, the next, based on the current set of information that I have. Very smart autocomplete, there you go. All right, you should trademark that if it hasn't already been. So, but normally, or I don't know, the simplistic approach is a greedy approach, and what it does is, for every word, and also probably some sort of past words, it can sort of have a probability for what's the next best word. All right, so in this case, nice is chosen. It's a 0.5 probability to be the next best thing. Then after that, it's woman, because it's 0.4. So the nice woman. So that's 0.5 by 0.4 is 0.2. So this path is 0.2. So that's the best sequence of words, right? Wrong. Because had it gone actually up to dog and then has, that's 0.4 by 0.9. That's 0.36. So that's actually the optimal sequence of tokens in this very simple scenario. So the point being is the greedy approach, where you just each step of the way pick the most highly promising, probable next step, isn't always going to give you the optimal result. And so you can actually tell the LLM to go through multiple paths at each step of the way. It's called beam search is what it's called. So in this case, number of beams is 2. So we'll try 2 paths at each step, and then we'll keep the current best sequence of tokens that gives the highest score, and then at the end of it, that's the one we'll return. And so this is something that's like conceptually pretty straightforward. Once you run this in an LLM, it can be painful because these models are big and they tend to be slow. They take a lot of memory, but relatively easy to implement. And so, like when we did this with, we picked just one of the foundation models that had a sort of a decent factual consistency rate, and just by saying, let's look at 10 paths every step, 10 options every inference time, and then we'll see if we can find the best sort of global optimum. Just by doing that, and like literally just a configuration in the call, we got another 2.1 points improvement in factuality rates. So very easy to do, no model changes, but inference is slower, and it's already pretty slow. But sometimes that's okay. So the other main approach we're looking at, and this one's a tougher one because this involves fine-tuning and training the models. So I mentioned we've got the foundation model, or I'm sorry, the LLM that we use that's optimized for RAG. So we sort of fine-tuned it to hallucinate less and to do better with giving citations for explainability and things like that. And so the approach, we created this thing about a year ago, and we're in the process of improving it now using an approach like this, which is at high level, we start with the foundation model. So in this case, it was just an open source foundation model that these things, they understand the distribution of language really well, so they can predict the most likely next best token, or the next best autocomplete suggestion. So they know language really well. And then we did a supervised fine-tuning, which is basically a lot of labeled data. So we just have a whole boatload of prompts, and we had a person that go in and says, for this prompt, this is a good result. And then we fine-tune the model further to that. We're essentially fine-tuning it to stay more faithful to the information in the prompt and to draw less upon the parametric knowledge that it has in the neural network from its training. Then after that, we do another round of training, this time reinforcement learning, again with human feedback to, again, sort of nudge it in a certain direction towards style and controlling for toxicity and things like that. So this one's a pretty, it's effective, but it can be pretty labor intensive and cost intensive, especially at training time. But the good news is it makes inference time, there's no change there. It's just the model, it's just what it was always been doing. No multiple beams and stuff like that. But yeah, it's extra resources needed. But again, just doing this on top of the basic level, we got another 2.6 points better. So all these things sort of add up incrementally. It's the last mile is tough with this sort of thing. So you have to stack up these approaches to get closer and closer to a good end result. And essentially, you know, this is true for us in our platform. It's a RAG platform. This will be true for any other application that's doing this sort of stuff. So the current sort of state-of-the-art approach here is make sure your LLM has been tuned and trained for being more factual, and then get multiple results coming out at once, and then use the detection of hallucinations to pick the one that's most faithful to the facts that was given to it. And then if there's still hallucinations, go in and surgically correct them. That's how you can get to maybe not 0% hallucinations, but a lot closer to 0 than what you get with just sort of plain LLMs out of the box. I got some demos in a second, but we'll do a question first. Yeah.
So, when we're doing the beam search, so beam search is based on the embedding or like based vector embedding from a RAG class?
No. Let me go way back to this guy. I'll get rid of those words. Okay, so this is it's sort of like a RAG pipeline. If you're not very familiar, data comes in, you have to extract the text out. It could be the text, it could be tables or images. I know there's a question about multimodality earlier. Get the information out and use an embeddings model to build the vectors that represent the meaning of that data. Then you store those in some sort of vector store. Normally, there's also metadata and like traditional keyword styles indexes that are maintained. And then, so that's like constantly happening as the data comes in. Then at retrieval time, when someone asks a question, you also build a vector embedding of the question, then find the specific snippets or the chunks that are most relevant to that question. And so there it's using the vector embeddings. But once you, and then you re-rank it another language model going on here. Once you give it to the LLM, it's no longer vector embeddings. It's just the text. That it's the raw original text to which the retrieved vector embeddings like map. So what goes into the LLM in a context window is just text. Well, okay, so the way Vectara works is when data comes in, we store both the raw text as well as the vectors. And then so we use the vectors for the vector similarity. But when we give that to the LLM, because you can choose different LLMs, and they don't all they don't know what the vector embedding model we do, like they don't know anything about that. So we give that the text, the relevant pieces of text, the facts as I keep calling them, to the LLM, and that's what the LLM operates on. So then the beam search is when it's the LLM is trying to decide, like I ask a question, did Andre Agassi win the US Open in 2003 or whatever, like as it's sort of going token by token in the output, the beam search is when it's deciding which is the next token to return in the response, and the next, and the next, and the next. And it's using as context the facts that were retrieved from the data set.
Yeah, my question is about like the beam search that's happening, the top P and top K also sampling happens. So is it happening at this RAG inference time or like during?
Yes, at inference time. So, sorry, I missed your. I probably answered a really long answer that wasn't relevant to what you asked, but yes, inference time. Yeah. Okay. Yeah. I'm not honestly. I don't know. I'd have to talk to our ML team on that. I mean. Yeah, so I mean, I know the temperature can sort of adjust the level of randomness. I mean, I would say that they're probably sort of orthogonal things. Like the beam search is trying to find the almost like the deterministically most optimal path through, but then the temperature is shifting things around to introduce randomness. Yeah. Yeah. So I think they're orthogonal. Okay, let me, I think that's it on the slides. Okay, I got to this guy. Oh, yeah, that's it. We put out a benchmark to make it so that you can also work on techniques for reducing hallucinations in the RAG context. It's one of the things we did with the community here. So let me switch over to show some examples here. Okay, so this one, this is the first time I ever did this demo in Illinois. This is a simple Q&A application. It's calling our APIs to build like an AI assistant for answering legal questions. It happens to be the Illinois Legal Aid online website. So this is like finally this is relevant to people I'm presenting to. So the first feature in RAG, in hallucination prevention is if you don't know, don't answer. Okay? So it's also really perfect timing for me to ask this question. Who won the last Niners-Bears game? You might know who won the last Niners. I'm from San Francisco. Anyone know who won the last Niners-Bears game? So this is So ignore all the rest of it. Like this is a feature, not a bug. Like we don't know because this data does not exist in the training set. And that's good. Don't answer if you don't know. Okay. So sorry, I had to have some fun there. But let's make it more relevant. So can my landlord kick me out? And so traditional RAG stuff, I asked a question, found a bunch of information, in this case, a whole bunch of search results that are relevant, and then a generated answer that summarizes the response in a nice human readable way with these citations. So like this bit of it came out of result 2 here. But the thing I want to show here is like this little badge in this sample UI. We give a confidence badge for like how trustworthy is this response. Put another way, how faithful was the LLM to the information given to it when it generated the final response, or did it stray from the script, so to speak? And so that hallucination score I talked about earlier, for this data set, the distribution sort of above 0.4 to 1 means it's like pretty good, you can trust this. A bit lower, maybe you want to go double check some of the sources, and if it's too low, then you as the developer probably wouldn't even show the answer if it was too low. The point is give transparency because they can't not hallucinate still, so at least we can give transparency so you can decide what to do with the answer. The other one here, so that shows hallucination sort of prevention via RAG as well as detection. And then the last one here is not printing. This shows an example of hallucination correction. So we took the scripts from Star Wars. We tried to pick a data set that's like as universal as possible, so sort of one of Star Wars. Put those into Vectara, and you can ask a question, and then what we do is we like force it to hallucinate, and then we use that hallucination correction technique I talked about earlier to fix it, like the things that were hallucinated. And so in this case, who is Luke Skywalker's father? If you know the answer, don't yell it out. Everyone's probably seen it, but there might be spoiler alert here. So what's happening is it's getting the question answered from this set of data in this RAG application, and then it's forcing it to be wrong, then detecting where it was wrong, and then correcting it. So yeah, his father's Yoda, right? No, it's actually Anakin Skywalker, also known as Darth Vader. Surprise if you didn't know that. So then this is the corrected result. So again, surgical correction. And then the last one I'll show here, what planet is Luke from? So this one, when I was forcing it to do the wrong answer, I actually hallucinated. I confabulated. It was like Mos Eisley. Like, does anyone know what that is? That's not a planet. That's the port on Tatooine where he's from Tatooine. It's going to say Naboo, but that's wrong. But I realized that I was like, Mos Eisley is a planet, but it's not. I truly thought it was, but that's just like a city on the planet. And so I guess the cautionary tale there is, yeah, we do it a lot. We're not scored on hallucination rates, but we probably wouldn't do very well on the leaderboard. But we should just sort of always keep that in mind when we're doom and gloom with LLMs of like, oh gosh, they're making everything up. Well, like, so do people. They're not doing it on purpose normally. It just sort of happens. But again, in certain contexts, you have zero appetite for hallucinations. Like in the business world, it's got to be as close to zero as possible, hence all the work we're doing. But yeah, Luke is not from Naboo, he's from Tatooine, so I'm glad we got that sorted out. So anyway, that's it. I can do any questions now, and we'll be around afterwards if you guys want to chat about any of this stuff or just RAG stuff in general. I know that came up a couple times in the questions. So yeah. Okay, I'm going to go back to front, in the back, yeah. Yeah. Well, okay, so there's a couple ways to look at what's true. In the context of RAG, we're actually not trying to like optimize for what's the objective truth, because in a lot of cases there is no objective truth. What we're trying to optimize for is factuality. How faithful is the final result to the data that was put into the system? So I could put in a whole bunch of articles saying Michael Jordan's the best basketball player ever, and then if I ask the question, who's the best basketball player ever, it says Michael Jordan. It is being faithful to the information that's put in. But people from LA might argue that it's Magic or LeBron or whatever. And so the main point is you have to look at this in terms of factuality and like faithfulness to the data versus objective truth. That said, you can certainly do things like in that pipeline that I showed, the 1 through whatever, like you can provide your own LLM prompt and have it be more subjective, put in some amount of reasoning, do some few shot learning to get it to do some additional stuff versus just sort of dump out a paragraph summary of the retrieved information. And so in that case, in the RAG context, you can still let the LLM provide some amount of judgment or subjectivity. But if there's no objective truth, like that we could agree on, then the LLM won't know either. But what you really need to do is just be faithful to the information that's there. We'll never know. Yeah, Michael Jordan is the best basketball player. We do know that. That's subjective. Right, the white sweater?
So in terms of like API calls, like because you're doing this action, is that only one cycle or does
I'll answer it from the perspective of our platform. It's one. So what happens is, I'm not going to go find the slide, but there is all that stuff that happened. There's like, we have a query API. It could be a chat or a single question, or it could be one tool call in an agentic workflow. That does the retrieval, the re-ranking, the generation, and the hallucination scoring. Pretty soon, there will be an option if you also want to do the correction, it will do the correction. So from our users' perspective, that's one API call. Now, certainly behind the scenes, we're hitting up lots of language models, some that we host, some that are hosted externally, depending if we're running in our cloud SaaS or an on-prem, like there would be no external ones. I know on-premise came up a lot today. But yeah, behind the scenes, there's lots going on, but from our users' perspective, it's just one simple call. And we're trying to just, a bit of the sales pitch here, like we're trying to make it so users can live at a level of abstraction that's one higher than like the RAG plumbing. So think in terms of what data you need to put in and what questions you want to ask and how do you want to tune the options for how the question is answered. Don't think in terms of tokens and LLM calls and prompt engineering and hyperparameters for how we're saving the vectors and the vector storage. Like that kind of stuff, we know how to do really well, others know how to do really well, but most developers probably don't need to be mucking around at that level. They should just think at the higher, if they're like their business requirements. So yeah, one API call to the user, multiple API calls behind the scenes. Simplest way to look at it. We optimize for latency. We also have options to for accuracy, like the re-rankers. If you turn on the relevance re-ranker, that adds a bit of latency, but you'll probably get a bit better, more accurate response because it's ordering the results in a better way. If you pick GPT-4 over GPT-4 Turbo, it's going to be slower, but probably a little bit better on the response. So yeah, there's some trade-offs, and those are the tunable knobs that we have on the API. Oh yeah. Okay, there was one. Go on.
So, how are you calculating confidence score? How does the LLM know what is the right answer?
I'm trying to remember where you like. Oh, that's in the Beam search stuff. Oh, this way. Oh, yeah. Okay. That is okay. think of that pipe here. Let me just leave that pipeline up. Okay, so user asks a question, retrieve, rank, generate. This is the hallucination scoring model, the guardrails model. It's called lots of things. This is the one that gives out the score that you're talking about. This is just, it's an MLM, a medium language model. It's pretty big, it's not huge. That's the one we open source, the leaderboard thing. This guy, he takes as input a user question and then basically a prompt. So the prompt has all the context, all the facts that were retrieved. And this guy's purpose in life is to quantify, and also the LLM's output. This guy's purpose in life is to sort of score the LLM's output on how faithful it was to the prompt that was given to it. And so that number, the 0 to 1, is just a normalized, basically the end result of the neural network that this model is. It normalized 0 to 1. That's what that specific score is. So like 1 means it's completely faithful to the information passed in. 0 means it made everything up. And then everything in between is on a range. Sorry, I was confused because we've got lots of scores. There's relevant scores of the retrieved facts. Then like in the LLM, there's the dog has those things, those numbers. How much time do I have? I don't want to eat up all of. Okay. So yeah, there were a few more. We'll go here, then there.
When you were correcting, right? So the quick correction you had there. Are you doing the evaluation, getting a score that's low, then rerunning the LLM, or what are you until you get that higher confidence number? No.
Yeah. It's a different model. Smaller, cheaper. I don't know the details of exactly, obviously, so yes, we can score it. I don't know the details on exactly how it finds the specific hallucinated parts and corrects them. So the short answer is, I don't know exactly how the architecture of the model, works to do this task. This one's in active development. This is sort of like a summary of where we got as of about a month ago, but we're still working on it. Yeah.
So I had exactly the same sort of question. How are you finding what's wrong, right? Yeah, you're hallucinating.
Yeah,
how do you find the hallucination is the biggest.
Well, so think about it. The LLM gave some response. We also have all the facts that were put into the context, and so we know in this case the objective truth is the facts that came in, and so you think of it almost like, are you familiar with Rouge or Rogue? I don't remember how you say it. It's like a semantic similarity algorithm. Like there's techniques to sort of tell how semantically equivalent two pieces of text are, and like where they convert. I don't know exactly the technique that's used, like I said, but the point is it's actually a relatively small problem because you just have a bunch of tokens of facts and then you have a bunch of tokens of LLM output, and you sort of just compare the output to the facts and the text and find what's off.
Coming from your RAG vector database, or?
Yes, yeah, like the top K results from the RAG, the retrieval, yeah.
Okay, top K results compared to what's coming from the LLM, and you're comparing.
Yep.
So you're just comparing your faithfulness to the RAG information, not to the potential actual correct.
Yeah, because who knows what, yeah. Like who can, the problem is who's the judge, right? It's like LLMs all the way down, the turtles all the way down thing. Like at some point there's no objective judge of what's true, so you sort of have to fall back on, it's just got to be faithful to the facts that you put in for your application.
Yeah, I was talking to someone about that, right? So facts also change over time. Archaeological facts, and you find missing links, you know, and stuff like that. So it gets modified over time. So facts also change. So
Yeah. I mean, geez, in our political climate too, facts change every month. So.
that's a whole different
Yeah. Okay. All right. Thanks. Thanks for letting me go over. I'll be around. So. You're going right? Yeah. Good luck. Good luck getting the screen share to work properly.
Yeah, I might have to ask you.
Oh, thanks. Yeah, yeah, definitely. Yeah, that's why we were chatting earlier. It's like we haven't talked a lot with IBM about like, partnering, but which doesn't make a lot of sense because like we're like square on the enterprise too.
Right away, right?
And I'm very familiar with the IBM suite. I used to work for IBM. I used to work for Red Hat. So like it's been a while, but like I sort of know how you guys roll. So yeah. So yeah, let's connect.
Hi,
Hey.
my name is Dhanvant.
Hi.
Hi. So I got a few.
Wait, hold up. I forgot.
Oh, yeah. Yeah, come on over. Oh, you're leaving?
No, I'm just packing my bag.
Yeah, can you leave it for until it's, are you going to stay till the end or you're leaving?
I might leave in the first.
Oh, okay. Yeah, so this is, yeah, let me go.
I mean, if it's not charged, I can wait. If it's not charged, I can wait. It's okay.
No, no, so this is attached to this one.
Oh, okay.
And how much percentage is that? It's a 47. Huh? 47. 47, yeah. Should be okay. Yeah. Oh, the other one. And we can attach it to. And we have sound here? Okay, cool. Okay, guys, maybe start. Okay, great. So I'm going to talk about not so much on LLMs, but the problems regarding LLMs. So we all know there's problems with hallucination. We just had a nice talk about hallucinations. There's other problems. What we want to do is to have LLMs that work perfectly well, give us the facts, don't lie to us, and have some responsible and trusted results. Right? So that's the feature of my talk. I'm just going to cover certain things at a higher level, bring you some of the information which is still being worked on. It's an active a research area. I'll point to certain papers that I've been looking at, but this is not a perfect solution yet. Hopefully someday we'll get there, but that's the goal. Okay, and that's me. And if you want to connect with me on LinkedIn, that's where I am. Okay. Okay, how does this work? Oh, okay, it does change. Okay, so let's talk about where LLMs and artificial intelligence is being used in today's world. There are different applications. Everyone's talking about AI. If you don't have some AI in your application, no one wants to use your application. We have come to that point, whether it's useful or not, whether it actually produces any results or not.
whether it's enhancing anything or not, you have to have some sort of AI in your apps, or people are not interested. Oh, you're not using AI, then what is the app doing? Okay, so the first use case that we are looking at are customer assistants. So there's lots of customer assistant apps. IBM actually announced they reduced their HR staff by almost 90%, right? And we have an active actor, which is monitoring all this stuff and answering questions. Good or bad is a whole different story. It's sometimes frustrating talking to a machine, like even on the phone, right? So, but a lot of these apps are basically what we have today are chatbots, right? Most of them. So I'll go back, not just today. The first time I really got involved with AI was a project with Rehabilitation Institute of Chicago, which is now called the Ability Center. So what we were trying to do was they had embedded AI in the prosthetics, the prosthetic arms and the legs that they were retrofitting with their patients. The problem is when they take those prosthetics work perfectly well, they're great engineers and AI developers at Northwestern University. The problem is when they take them home, they don't work as well. So we were trying to see what the problems are, and what we realized is either they're not put back properly onto the same prosthetics, you can take it out, put it back, so the patterns that you identify changes. So many things happen, and that was one of my projects that I proposed for the Watson Challenge. We went to the finals, didn't get selected. All that got selected were chatbots. And you wonder why. Everyone's using chatbots, okay? A little frustrating, but yes, that is the mostly used apps that we have. Now, if you look at chatbots, instant messaging, you'll see 73% of the apps are like that, right? Mostly from customer care and sort of things. Email responses, 61%. Though I was just reading a paper about email responses. If you give a chatbot access to your email, other things can happen too, right? So if it misreads the email or something like that, hallucinates or whatever. So there's a whole paper on it. I didn't read the whole paper, but at the end, the author is suggesting don't give access to your email. That's the only solution to this. But anyways, it looks like 60% of people are using this. I was surprised, actually, in one of my meetings, I hold a meeting every Thursday and Fridays with students and professionals. Some of you joined from here as well. Luke recently joined. He's studying at Illinois Tech. And I was doing an IPER project with him. Anyway, so I suddenly see someone joining in, and it looked kind of weird, okay? So I don't see anyone's face or something, but it's a sort of a weird thing. And then we realized, okay, I can't let this guy get into my Zoom and listen to it. Happens to be a robot. Apparently, people are using robots to listen to their calendar invites. I forgot the name of the company that's producing these links. So they'll record it on their end without my permission. Obviously, without my permission, they can't start the recording because I'm the host. So that's a good thing. Or else they'll be hacking into the Zoom itself, which is a big problem. But people are doing this. So that's another sort of application that we're looking at. Product recommendations. This is a big thing started by, I think, Netflix. What movies you want to see and all that stuff, right? So based on statistical information, nothing wrong with that. Text messaging, 49%. I wonder what they're doing. They're probably, I'm trying to create a Discord bot as well for the open development, probably things like that. But anyways, I don't want to go through all of that. But this is where we are today. Now, this was mentioned before in Matt's talk, right? The pillars of responsible AI. So one of the problems with the AI is explainability. So where is the data coming from? What are the citations from the data? The biggest problem that I see with LLMs and all these models around is you have no reference. So you can try to keep some of the metadata, and people are doing that. Even IBM is trying to do that, and cite the data and see where it's coming from. With RAG models, it's easier because you have you're searching. It's more deterministic, and you have certain level of confidence in the data that you're retrieving. And then you can say, okay, I got this data from this place, and so on and so forth. So you can save the indexes to the actual text and say, okay, it's coming from here, so here's the citations. So it is possible. But in most cases, it is very, very difficult to find out. There is a tool, I'll come to it later, called AI Explainability, which was an IBM research tool, and it's open sourced. It's on GitHub. Try it out. Let me know how well it is. I haven't done so much research to see all different scenarios and see. It does work, and it is pretty good. So try it out. It's from our research. It's open sourced. Fairness. So is there any bias in the data itself, right? So that is a huge, huge problem. So like what we already know is healthcare data. As it stands today, it's very much biased towards Caucasian sort of sampling, right? So the medicines that are even suggested without LLMs, we're not talking about LLMs, just the normal data, the statistical data that doctors are looking at is biased itself. So if you train an engine with this biased data, what are you going to get? You're going to get biased answers. So it's a huge problem. So the data itself that we are training it on has to be tested. And how we are testing it? Again, there's a tool that determines whether it's biased towards one race or another race, towards males, females. I'll come to that. I have a link later on. Okay? Robustness. So there's adversarial attacks that are coming in. So this is a very interesting example, right? So you have a panda, and you introduce this noise. This is a famous paper. You introduce a noise, and then you cannot identify the panda anymore. The LLM model, to us, it looks like a panda. To me, at least, it looks like a panda. Hopefully, it looks like a panda to everyone else. But to the LLM, it looks like a capuchin monkey for whatever reason, because of the introduction of these noise. The problem with this particular noise is it's not just any noise. It's generated by certain algorithms, which are again outlined in the paper, to fool the structuring of how the LLMs are working, right? So it is a researched output of this noise, which is introduced into the picture. Well, if a panda is not recognized as a capuchin monkey, it's fine, right? What about stop signs? And this has been actually tested with stop signs as well. So not this exact noise, but every noise is researched out of another model, which is introduced into the picture to produce the final picture. So if it is a stop sign, you're driving the self-driving car, it doesn't see the stop sign, it just goes through. That's dangerous. So that is a problem. Now that we know this sort of noise exists, there's other models that are actually checking for these before it's introduced into the larger LLM models. So the known ones are already being taken care of. What if someone comes up with another one which you don't know? That is where the problem lies, right? And do we have a great answer for it? No. Transparency. So if we don't know where the data is coming from, it's hard to determine what the transparency is, right? But there are AI fact sheets. We can check against the fact sheets and see, like my friend over there was doing, right? Checking against the results from the RAG, whether how much factual it is, and see whether we're doing the right thing, okay? And obviously, privacy is an issue. Okay, so now let's look into some of the attack surface for generative AI, right? And this is to me a very evolving and very interesting field. It's like viruses for LLMs, right? So we have prompts. Now, what people are doing, yeah, if you write some prompt, you get some answer. It's fine. You get a wrong answer, hallucination, that's a different problem. But this, what people are doing are malicious prompts called prompt injection. So you can do direct prompt injections. So hackers can put like special markings and stuff and get information out of the thing, or the replies will be totally incorrect. And they're just putting this layer on top, right? So it's a huge problem. Now it can also be an indirect one. So you're referencing a website which has incorrect information on it. So you're redirected either to Wikipedia or maybe to a website that you created. And that's the indirect way of prompt injections. Okay? So these are things that we need to be careful about. Infection. So LLM has a whole chain of things, and I'll come to some details in slides after this. It's a whole chain of events. You take data, you get the data from somewhere, you have to save that data somewhere, you have to secure that data. That data trains some model. There's opportunities of having problems there, and then you have some inferences, and then something happens, right? So it's a whole chain, a supply chain issue, right? And people are infecting that supply chain, and we need to be aware of that. Evasion. Evasion is more like adversarial attacks, like the capuchin monkey case I was telling you. But these are very, very specially designed prompts or something in the data that people are infecting the LLMs with. Poisoning is another problem. So there's a paper out there. I forgot to put the link in here. I'll have to find it again. The interesting thing is, the attack success rate is 97% from a 0.0002% of data corruption inside the RAG model, right? So with the data you're putting into the vector database and retrieving it, if there's 0.0002% of the data is corrupted, then you get 97% of wrong answers. It's a huge number, okay? Prompt leakage. What people are trying to do is send some prompts, get information out of it. Say the social security number or something is inside the model, right? Or some information, say your name. Who is Ron, right? What is his LinkedIn? Maybe I don't want to let people know about my LinkedIn, though I want you guys to message me. I have no problems with that. But maybe I'm trying to hide it from some people. And people are trying to get these information out, right? By engineering the prompt. It's a big problem. Denial of service. Not just the normal denial of service, but people are engineering stuff that increases the search capabilities inside your LLM, right? So it introduces searches that are unnecessary, right? Just because of the prompt. So it's a recursive nature of the prompting that is being fed in. So this refers to this, and that refers to something else. And now the LLM consumes a lot more memory. It's charging you a lot of money, and eventually it stops, right? Let's look into prompt injection in a little more detail. And if you're interested, read these two papers. They're really nice. The attention tracker. Okay, so this is the paper, and it's also on Hugging Face if you want to try it out. Basically, what they're trying to do is distract. So like a magician, right? So I'm talking about something, and you distract me, and then I start talking to someone else, and something happens behind my back. So that's what's happening. So if you look at the picture, so the attention was on the output here, and now with this distraction mechanism, they've diverted the attention to those two objects over there, right? And that can cause a lot of problems in how you reply to the error. And these are all algorithms that people are working on to come to these prompts. Okay, some examples are there. More details are in that paper. Infection. So I was talking about the whole life cycle and the whole supply chain of these LLMs, right? So you have the app store, you have these application builders at the bottom, then you have model preparation, and then data sets and all that stuff. And anywhere there's vulnerability, it's a problem, right? And there's certain things that can happen which are very, very simple to stop, right? Like in most of the hacks that happen, people have not taken the simplest measures, right? So they haven't closed a port which was already published to be problematic, or some plugin or something like that, right? Oh, plugins. That's a huge problem because people are using plugins to do their jobs for different LLMs. They're downloading LLMs which are from open source projects. Like normal open source can be infected by viruses. It can also be infected with other biases and all kinds of things, right? So the supply chain is very important. Infection. Evasion. So you design things and you add some advanced prompting to it. So basically what you're trying to do is confuse the LLM for answering certain things, right? Again, some research papers are here. These are all active works, but we need to be aware of it as we go forward, okay? Poison. Poison is the simplest thing to understand, right? So you're saving data. This is a very simple example. So CEO of OpenAI is Tim Cook. That's how the answer is. And maybe with your system, Matthew, you can detect these sorts of issues, and right? Prompt leakage, as I was explaining. You introduce certain things, and the function calling and querying algorithms basically retrieves information that you don't want. So that's one of the problems. Again, some of the research papers are here. Risk mitigation. Okay, we don't have great risk mitigation for any of this, but we should try to do certain basic things that can solve 90% of the problems, right? So user inputs can be checked, right? Rather than just getting the user inputs directly into your LLM and using it in your application, you can have a layer in between of abstraction, right? Checking what is coming in, what is not coming in, what type of prompts are coming in, certain like those series of exclamation marks. That is a very known pattern that people are using for infecting the LLM. So you can check for those very easily, right? Let's do the simplest thing. Infection, evasions. Evasion, it's very difficult to detect or obstruct because they're very, very carefully orchestrated algorithms. These are like research papers people are publishing. Imagine people who are not publishing is the problem, right? If people are publishing, okay, these kinds of noises can create a problem, then it's fine. You can take care of it, right? It's like ethical hacking. But if people are not publishing them, then it's a problem. But fortunately, there are people working on it as well. So adversarial detection, these networks have found pretty useful. I haven't done any evaluation, honestly, to see which ones work better. It needs a lot of research to actually determine which one is better than the other. I'd rather call all of them in our supply chain as we're doing the ML ops, as we're building and then deploying. We should call some of these networks and see how it goes, okay? There are certain very specific things related to RAG, okay? So one of the problems is hallucination, which RAG is trying to solve. The bigger problem with all these models is the data drift and the model drift, okay? So the data that you're training the model with is changing over a period of time. And the model cannot change. It's kind of static, though the data is changing. And that's a huge problem. And the model drift. So as time goes on, and you're retuning and fine-tuning and doing all this stuff, you see the same data is not giving the same results. Obviously, all of this is probabilistic. It's not a deterministic thing to retrieve the same thing every time, so it's understandable. Even if you put the temperature down, we were talking about temperatures, right? Even if you put the temperature down to 0, you don't get the same results, right? For even like the simplest things, sometimes you get it, sometimes you don't get it. But over a period of time, what happens is there's a model drift. So you have to constantly test the model and see how your results are and validate those results, right? That's the only way to detect model drift. Data for training and test models. So just giving you an example of where all these data can come from. Say for the aviation example, we're comparing question and answers from logs and CRMs. We're getting data from tracking systems. We're even going to the weather service. So I worked with them very closely in the past, re-architected the whole data center for NWS. Any flight, before it takes off, it needs a whole weather pattern from point A to point B, where it's going, and any of the points in between. So all this data is required. The weather data is a very important data. That's why they're part of Department of Commerce, which was always strange to me. Why is it part of Department of Commerce and not other department? Because it's so important that there's a commercial factor associated with it. Okay. Some of the boring papers we always have to take a look at, the NIST reports. Okay. So there are two reports mainly. One on it's called adversarial machine learning. It outlines all the different aspects, and some of them I've already talked about, of these LLMs. And this is so NIST papers are not like absolute regulations that you have to follow. It's more like a suggestion, but it's a very good suggestion. If you don't follow those suggestions, you'll probably be in trouble in the future. So take a look at these two papers. They have a lot of details in it. Less information about what exact models to use and stuff, but they're very good reads. There's another paper that came out very, very recently. This is November 18th. It was published, the OWASP Top 10 for LLM applications. Do take a look at that as well. And I think I've provided I didn't provide the link of the NIST, but you can just search. It's very simple. Data privacy and AI laws. These are regulations that are coming up or already there, and we need to be aware of them. And we need to follow these rules and regulations, not just where the data resides, but their actual acts. Like in India, they published the Digital India Act. Then EU already had the AI Act. These are very, very specific rules and regulations for that specific country if you're using AI, like the privacy laws. So do take a look at those. Essential tools in the MLOps pipeline. So these are the two things I was referring to, the AI fairness at 360 and the AI explainability. Okay, so they're just libraries. Use those libraries. These are essential tools that you can easily use. They're free of cost, and take a look at them. Securing the pipeline. So what needs to be secured? First of all, you need to secure the data, the access to the data, and all this stuff, classification of data. First thing you have to do is who gets access to what data, right? What is being fine-tuned? What is being used to fine-tune models and things like that. So the data is the first place where there can be issues. The model itself, like infections, API hackings, and all that. API hacking is a interesting problem because most of the models are being actually accessed through an API, and the API itself has vulnerabilities. There's a product that we work with very closely. So we have a product called API Connect, but there's a sister product called No Name. We don't own the product. It's a partnership we have, but No Name actually looks for certain specific, and there can be other products. I'm just familiar with No Name. That's why I'm mentioning No Name. There are products that actually look into vulnerabilities in the API layer itself, and that is something that needs to be looked into as well. Okay? And these are very important things, these two, the data drift and the model drift. Because over a period of time, the results with the same data can also deteriorate, and the data itself changes. So they're both problems. And the biggest problem is the data and the decision making is inbuilt into the LLM itself, right? If the data was external, like we have databases for applications, this wouldn't have been the problem, right? Inference. So prompt injection, denial of service, all that stuff falls under the inference part of it. Don't want to repeat it again. Okay. And that's it. That takes me back to the end of the slide. And thanks for sticking around, and have a great, great holiday. Just wanted to end the AI camp with a good note. Okay. Thanks, guys. Any questions before we end? Absolutely. Nothing is random. It's engineered. If you look at the equations that they came up with, the algorithm is very, very complicated. I could not understand the whole of the algorithm, but I trust it. It produces noise like that, which is very, very specific to confuse the LLM. So what they're doing is they're analyzing the algorithms that that LLMs are built on, how they're looking at the least curves and things like that. And they're trying to re-engineer something that actually can counteract some of these algorithms. So it's a paper written. That's why we know about this. There might be other things that people have not published, which is scary. Yes, it is. That noise is not random. That noise is specifically created to confuse the LLM, to give the right answer. It's the same data, the same LLM model, wrong answer, with the introduction of the noise. That is the scary part. Okay, anything else? I'll be around, packing up stuff. So, and have a great holiday. We'll meet next year, 2025. Hopefully, this we can keep on doing. So AI Alliance is a great group to work with a lot of. So I think Meta and IBM started the group. So AI Alliance is also sponsoring today's, as well as you guys. What's your company name? Vectara. And AI Camp always brings these things together. So I'm grateful to all of these guys for a wonderful year. See you next year. Okay, thank you so much. Good. Hey, how are you?
I didn't catch her name. I'm sorry.
Ron Majumdar.
Ron. Okay. I want to connect with you on LinkedIn because I have a lot of questions. Is it fine if I ask you now?
Yeah.
Okay. So when you say about the model drift, right, the data drift. So let's just say a common example of what OpenAI did. So they kind of released GPT 3.5 last year, right?
Yeah.